Hi all, this is the badging video for the surface grinder here at MakeHaven. A surface grinder grinds surfaces of materials, generally hardened steel is the typical material. And the reason you use it is one, because it can cut things like hardened steel more easily than you can with other tools, but it specifically is good for getting to very, very fine tolerances. If you want a really precise dimension, then often a surface grinder is going to be the best tool for that. So we often think of grinding as like abrading away the material as though you're like rubbing it off, but in reality, a grinding wheel has lots and lots of little cutting teeth on it. So each little bit of grain is actually a little cutting edge, and what sort of defines the ability of a tool to cut something to a certain tolerance is how little material you can remove at a time. And on something like an end mill, on a Bridgeport, there is sort of a minimum amount of material that you can remove at a time before it just kind of is rubbing against your material. And on a surface grinder, it can remove a very, very small amount of material at a time, so you can get to tolerances of 1,000th of an inch with relative ease, and sometimes even smaller numbers than that. So that is why you would use a surface grinder. As I said before, it's generally used for hard materials. It is only used for ferrous things. So you can't do aluminum, brass, anything like that. Those will just melt and gum up the wheel. So only steel, only ferrous things, and in general hardened steels. And you can tell it's hardened a few ways. One is by taking a file and trying to scratch it, and the file will just sort of slide right off of it. If it's hardened, it won't even be able to make a mark because it's harder than the steel of the file. Another thing that lets this cut hardened materials is because the ceramic is very hard and very heat resistant. So if you're trying to use a carbide end mill, it might be harder than the hardened steel, but it'll heat up and get really hot, and then it gets soft and it becomes a mess. But these ceramic particles in the grinding wheels don't get so hot, and so that allows it to cut things that are very hard. There are ways to get even finer tolerances. If you want something to be super duper duper, either smooth or flat, or to a very high level of precision, using honing or lapping or polishing something, you can make it super duper shiny, and that's when you know something really flat and smooth, when it's shiny. But this isn't quite that level of precision. In terms of safety with a surface grinder, really the big thing is, number one, making sure that your hand isn't anywhere near here while the wheel is spinning. So you want it to be completely stopped before you demagnetize the chuck and remove your piece or get your hands anywhere around there. And then two, you always need to make sure that you aren't doing anything that might damage this wheel or the spindle assembly. If you do that, if you jam something up in here, then it could explode, which is obviously very dangerous. This thing's spinning really fast. But that would also potentially damage or ruin the machine. So you need to be very thoughtful when you're using it about removing teensy amounts of material and not doing something that could jam it and crash the machine. So in terms of just kind of going over the anatomy of the machine, we can just start sort of from the top. There's a little oil reservoir up here. So you want to make sure that there is whey oil in there. This is whey oil, and there's more oil over on the shelves. Make sure you whey oil. Wheys are the surfaces that these tables glide on. They're called wheys. And this automatically drips down through the back of the machine, collects in this tray, and goes into a container in the back. So periodically we'll empty that container. There's another little spot right here, and so that is just a little oil cup that you want to also put whey oil in. So you just squirt some in there before you use it to make sure that it's moving, and you'll know that it's okay because this will move nice and easily. But if there's no oil in there, this will be pretty stiff. This is the spindle, and so there's this wheel on the spindle. It's a 1/2 inch wide wheel, and it spins very fast. This allows it to go up and down, and it goes by very fine movements, allowing you to get very precise depths of cut. This is a light here, switch on the side, and then down here we have some more controls. So this is what's called the longitudinal feed. So it goes sideways, and then this is the transverse cross feed. This is moving the table back and forth this way. So sort of like X, Y, and then Z. And each of these dials has markings on them, little gradations, to show you how far you're moving it. So you can make sure to move it only small amounts for however much you want. And then there are these stops here, and those allow you to move the table back and forth just a limited amount. So they'll stop you. You can adjust those if you want to for some reason. There's a cabinet down here with a few accessories if you ever want to change the wheel. We have a pretty standard wheel on there. If you did want to change it, that's something you should probably talk to a facilitator about to make sure you're doing that safely and appropriately, choosing the right kind of wheel. And we'll talk a little more about wheels later. This just collects the dust. There's a vacuum down here that you need to turn on when you're using the machines. The dust gets collected and we're not floating around in the air. And those are most of the parts, except there's a power switch down here, so that's also an important one. So in terms of actually getting started, right now this truck is magnetized. So the way this works is there are magnets in here, and you move them by moving this lever. So now the magnet is demagnetized, and you can take things on and off. Again, this only works on ferrous materials, so steels, and then you can lock it back on like that. Because this is cutting at such a fine level of precision, it's really important that this whole situation is very clean. If you have even a little bit of dust under there, it throws off what you're doing. So one of the first steps to mounting something on here is cleaning off dust. You can use a rag just to wipe everything off to make sure there's no dust sitting on there. And another step is to use a stone, and you just want to rub it around on the bottom facing material to remove any burrs or high points. And so what that'll do is make sure that there's no burrs or little things, little chunks of metal on there that are going to hold it up at a weird angle. So now we're done with that. I'm going to just put these two things out of the way. And we wipe the chuck off. And we're going to plop this down on here, and I'm going to lock this down. So the first step to using this tool is to dress this grinding wheel. So the grinding wheel has all these little bits of ceramic that are held in a matrix. So it's kind of like sandpaper, how there's bits of sand attached to the paper. And as those pieces get dulled because they are getting used up and cut back and forth, then the matrix wears away and exposes new pieces. So what you want to do when you're using this is we want to start by having a very flat stone. So we do that by dressing it. This is a diamond-tipped little stone, and we're going to run it across the bottom, and that will make sure that this grinding wheel is perfectly flat to begin with. So that's important. We're only going to remove a little bit of material just to expose the new grit, and that will make sure that we have a good smooth surface. Then when we start to actually grind something, this is just a piece of hardened steel, then when you go across, this stone slowly gets worn. So it's important to just use a little bit of the stone at a time when you're grinding, not the whole face, because then that whole face would rise up. So what you want to do is just start with that leading edge and move it over just maybe 10 or 15 thousandths of an inch at a time. So you're always just working on that cutting edge, and the stone is slowly getting worn away backwards. But in general, I could grind this whole table flat without needing to redress the stone in between, and so that's how you maintain the accuracy. If you're doing a big project over and over again, you will need probably to redress the stone, and you can see the wear on the wheel, getting sort of having dirt on it, and that's how you know that it needs to be redressed. If you are really doing something that you want to be super precise, you should redress the stone every time you start, you turn it off and turn it back on, because it'll need a teensy bit of rebalancing and just making sure it's perfect. But in general, doing it maybe once per time you're using the machine is sufficient. So we're going to start by dressing this wheel. Dressing is like sharpening a blade. In this case, lots of little blades. And so I'm just going to bring this over here and run our table over here. And so this little nub is aimed in the direction this is going to spin. There's an arrow on here showing the direction it spins in, and we want it pointed in the same direction. And the reason for that, I'm just going to bring this down. So the reason that we want this pointed this way is so that it can't pinch. If we had the stone over on this side and it was coming, it could jam under there and explode the wheel and destroy the spindle would be really bad. So we always want it to be on the trailing side. If this is the leading side, we want it on the trailing side. So if we bite too much material, it'll just push it. It might still break the wheel, but it'll be a little less catastrophic. So we want it on the trailing side, maybe half an inch over this way, and pointing in the direction that it's spinning in. So that's very important. And we're going to make sure we're not going to approach it from the side, so we're not going to come sideways into it, because we could accidentally grab too much and make a big groove. So we're going to come down very slowly on top until we just touch it. And then what we want to do is remove about 3/1000ths of an inch, 1/1000th at a time. And what we're going to do is we're going to go this way, go the transverse or cross feed in the Y direction, pretty much as fast as we can, because we don't want to glaze the wheel. We don't want to have a really fine, smooth surface. We want it to be kind of rough. So we just want to remove that material quickly. So we're going to turn this on, come down until it just touches, and then the numbers here are 1/1000ths of an inch. And then there's actually a vernier scale here, so that it goes down to 1/10 of 1/1000th of an inch. So normally we talk about 1 inch, and then 1/10 of an inch, and 100th of an inch, and 1/1000th of an inch. That's what these are, 0, 5, 10 thousandths of an inch. But then we have tenths of thousandths, or 1/10,000th of an inch, and that's what the vernier scale shows you. And getting a closer look at the indicators here on the z-axis handle, we can see that, let's say we came down and we touched our piece and we happen to be right at 15. That 15 doesn't really mean anything. It's not 15 anything. It's just a relative position. But then up here is 20, so each of these is 1, 2, 3, 4, 5, and then each of these is 0.5. So this is, focus, 15, and then 15.5, 16, 16.5. But let's say we wanted to go even smaller than that. So we wanted to not just do 15.5 thousandths, but we wanted smaller, then we can use these teensy little marks. So now, if we just go down one little bit, we're at 15.1 thousandths, and then 0.2, 0.3, 0.4, 0.5. And so now we're back lining up here, so 15.5, and obviously starting up until we get to 16. So that's how you use those teensy little marks. So those are tenths. So 1/10,000th of an inch is each of those little lines. So we're going to turn this on, come down, touch it, and then run across really quickly. And I'm going to turn the vacuum on. And just to kind of go over again what the dressing process was, is first we want to get into the ballpark area of this diamond dresser, and then you get this right underneath it. And then when the machine is on and the vacuum's on, you come down until it just touches. And what you can do, because sometimes it's hard to tell, this doesn't make sparks, is put your hand way over here, so it's not near the wheel, and you can feel the little bits of ceramic coming off, and so that's how you know it's just touching, because sometimes it can be hard to see. And then you'll run across to get that first initial surface, and then come down 1,000, run it back across, 2 thousandths, run back across, and then 3 thousandths. And get that final surface when you run it across. And then the wheel's dressed and ready to go. So I'm going to get this out of the way, and this is demagnetized. It's very important to make sure that this is magnetized when you're actually using it. If this wasn't, it would just throw your piece off. So magnet on, magnet off. And this handle can flip, so you need to check to make sure it's on there. Alright, so now we're going to try surface grinding this piece of metal. So I'm going to start by wiping off the surface, make sure all the dust and bits and pieces are off of there. And then going to grab the stone right over here and make sure there are no burrs on the surface, so it'll sit nice and flat. And what I'm actually going to do is, this side is not super flat. I think this side is flatter, so we're going to start with this as the bottom. So I'm going to stone this face. There we go. And that feels like it's sitting more flat. And we're going to lock that down. And then as we're grinding or cutting this, what we're going to do is come down until we just touch the surface. And we could have touched the high spot, and then so when we're going back and forth, we won't hit anything else. But we could have just randomly touched in the low spot, and that would mean that as we came across, we take off more and more material. And so for that reason, you touch, and then go across the whole surface just to make sure there are no big high points that you're going to hit, and then you can start taking off material. So some rules of thumb in terms of making these cuts are, in terms of depth, you want to take about 2 thousandths of an inch at a time. Obviously, until you get your final dimension, then you take whatever it is that you need to get to your final dimension. And then in terms of the cross speed, the transverse speed, you want to go about a quarter turn of the wheel. So that's about 25 thousandths of an inch. And that'll make sure that you're just using that leading edge of the wheel, back and forth and back and forth. So what it'll look like is, when we start the next pass, we'll come down 2 thousandths. So let's say we were at 20 right now, we go to 21, 22, and then go this way, and then turn this a quarter of a turn, and go the other way, and then a quarter of a turn, back and forth. And you just go back and forth, progressing a quarter of a turn each time. And it takes a little, a few minutes to get your brain and hands sort of working together to make sure you're going the right way with your hands back and forth. But you just work your way across the material. You want to make sure to exit the material from both ends. So you don't want to get just to the edge and then start moving, because then you're cutting with the side, and you don't want to do that. You want to get totally off and then move and then push. So you're cutting with the face over here. That's where you want the cutting to be happening. And it is very important to make sure that you're only doing 2 thousandths, because let's say we dropped it down 20 thousandths, then this could potentially bite and grab and cause all kinds of problems. So you're just taking off a bit at a time. And just to make sure that was clear, we're always cutting with this face of the stone, of the wheel. We're never cutting with the side. So you wouldn't try to put something up against the side. Now just as a point, while we're here, let's say we were trying to get this whole thing to be a perfect cube. At some point we would need it to be an orientation like that, so we could get this face. If ever something is taller than it is wide, like this orientation, then you need to have supports on it. And so what you can do is you can get 1, 2, 3 blocks. These are called 1, 2, 3 blocks because they're 1 inch, 2 inch, and 3 inches in dimension. And then you'll use these, and now you offer support to the material. And when it's held down, now there's no chance of it getting knocked over, jamming, or any funny business like that. So this is how you can stabilize your parts. Obviously they have to be steel for the magnet to work. to make sure that they're nice and flat. So I'm just going to put this back the way we had it. And one other note is that temperature can be a consideration. So this is a pretty hefty chunk of steel, but if you had something really thin or small, as you're cutting it, it will heat up. And as it heats, it expands and can warp and do funny things. So bear that in mind if you're cutting a smaller piece, to make sure that you're letting it cool between passes so that it isn't heating up and changing dimensions on you. And one last thing that occurred to me just as I put this down is you need to make sure that this chuck is demagnetized when there's nothing on it. Because let's say I just left this like that in the magnetized position and went to put this down on the table, it could seriously hurt my fingers. You know, or some random person just puts a screwdriver on it and slam, it'll get clamped down and could pinch their fingers. So I always want to leave it in the demagnetized position, put the material down, and your hand is a really good way to feel for little nubs on there. Your hands are very sensitive, so put that down, and then put this down, and now it is on there nice and tight, and we're just gonna surface this face. All right, so we're now pretty close to the right height, so I'm just gonna bring this over the material so that we can start by coming down onto it. And, all right, so I'm gonna turn the vacuum on, turn the machine on, and then we'll come down as the numbers go up, which is a little confusing, but this is the amount of material we're taking off. So I'll come down just until it touches, you'll see sparks. So don't need to put your hand over there, you'll see the sparks. And as soon as you see the sparks, then you can stop. And then we'll draw back and forth and cover the whole surface. And then we'll come down 2 thousandths. And then you stop when either you've reached a certain dimension that you want, but this is our first face. So what we would do is we would just get this one until the whole thing, we've seen that we've ground it, and we can see that it's shiny smooth. Then we would flip it over and do the other side down to the final dimension. Once we know that the reference side, which is the one we're doing now, is totally flat. Something else is that here, what I'm doing is I'm cutting in both directions, forwards and backwards. If we wanted to be really precise about this, so this is a bigger piece, you would just want to use one leading edge, because by using both, you know, we're wearing both sides of this cutting wheel faster, which is less good. You know, if you're doing a bigger piece, that might cause you some problems. You would need to like redress in the middle potentially. But here it's such a small piece that that's fine. So it takes a little while. It's a fairly slow process for moving material. And it got pretty hot in the process. We were putting a lot of heat into it, but Here, it is super duper smooth. You know, just I can see my face in it. It is smooth. At this point, we would want to flip it over and do the same thing on the other side. You know, wipe down the surface, etc. We would want to deburr the edges, so take the stone and knock off the burrs around the edges, because that will make it not sit very flat. In the process of grinding this, the piece got pretty hot, and so it expands. Metals expand when they get hot, as do almost all things. And what that means is, let's say we were trying to get this to a very precise dimension, it would actually be a little big, and then it would cool down to get a little bit smaller. So if we were trying to get this to be a perfect size, I would recommend getting, you know, moderately close to your final dimension, and then making sure it's totally cool, and then getting to your final dimension to make sure that you aren't having it be a little off because of the temperature variation, the heat from the cutting process. And you know, that's the process of getting something to be super duper smooth. In terms of cleanup, you just want to make sure to wipe everything down. You know, there's some dust accumulation here, so grabbing the vacuum goes out on the backside and vacuuming it up is not a bad idea. And then just make sure to turn the light off, and make sure that the chuck is demagnetized so no one accidentally gets their fingers pinched. And that is the very, very basics of how to use the surface grinder. I would encourage you, if you have any more complicated operations, to ask a facilitator, do some Googling, watch some other YouTube videos. There's a whole wide world of precision surface grinding to learn about, but this is just the bare bones safety basics. So thanks for watching, and have fun.